Let's see if we can put this turn signal together so it doesn't leak and doesn't twist out of alignment during operation. I already cleaned this up. There's quite a bit of corrosion there from leakage. With these turn signals, and I'm just going to use another turn signal housing to demonstrate, they're basically 4 different leak paths. The first one is around the perimeter of the lens. The second is through the screw holes. The third is at the junction of the housing and the support, right there. And the fourth is actually through the support, through the back of the support, because there's a screw that goes in like so, and screws into the housing. And so if water gets into this opening here, it can leak through the threads and get into the housing. It's very similar to a situation if you left your oil drain plug washer or O-ring off, then oil would, by capillary action, get through the threads, around the threads and leak out, or in this particular case would leak into the housing. As far as the first 2 leak paths, with this style of housing, and by the way there are 2, and you can see the difference. So this particular housing has a groove here that contains the O-ring that sits like this. By the way, these O-rings are, at least this is what I use, this is James Gaskets. Here's the part number right here, FXR Softail Sportster. There's another style for slightly bigger turn signals. Part numbers here, so these O-rings are a little bit bigger and I don't use them for the bikes that I have. Anyway, so yeah, the O-ring goes in here, and the advantage of this setup is that once the lens is installed, first of all, the O-ring is internal and is not exposed to sunlight, and secondly, as the 2 parts squeeze together, it's got nowhere to go, so it just retains and seals. So it's a really good system. This is my preferred type of housing. Unfortunately, this is what I have right now. I'm just going to keep running it for a while at least. And so the difference is there's no groove to retain the O-ring. What I do is I just put the O-ring around the lens, and there's kind of a lip here. And then, of course, this O-ring is going to seal, but the disadvantage is that it's exposed and it's going to wear out faster than the internal style. So you're going to have to replace it more often than the other style. So the second leak path that we talked about is through these openings where the screws go. And if you have the original Harley-Davidson screws, hopefully the camera can pick this up, there's a small groove on the underside of the head that receives this O-ring. And again, this is a really great system because the O-ring, very much as it is in this particular situation, is now captive in that groove. And so when you tighten the screw, the O-ring seals, but then the solid part of the head gets to push this lens against the housing so that a good seal is established between the lens and the housing by the large O-ring. So this is, again, my preferred way of sealing these openings and also helping seal the perimeter area. Now, sometimes these things get lost, so what you can do is just use a regular screw, like so. Unfortunately, using a rubber O-ring is not going to work. This is a panhead screw. Notice the size of the head is quite large. So this is a round head screw, so the head is much smaller. So if you used a rubber O-ring in this application, it would simply squeeze out and not seal and would get deformed. So, don't ask me how I know. And so it would be useless in this situation where you have a small head like this. So what I've done is I'm using an M3 nylon washer. Now, you don't have to use a metric washer. You can go ahead and use the SAE washer. This one fits perfectly as far as the OD is concerned. going into the lens here, but the ID was a little bit too small, so I had to use a couple of drills. Started with a 30 and then used a 29. Of course, 29 is a bigger size. And you know, the 30 you can just push through this washer, and the 29 actually had to use a pin vise. So essentially you just hold the pin vise and you push the washer over the drill bit and then just kind of move it back and forth, and then it opens up the hole. The advantage of, you know, using 30 and 29 combination is that you get to a situation where this washer just kind of stays. And this is nylon, so it's pretty soft, and it's going to seal pretty well. Okay, so now we've taken care of these two leak paths, right, around the perimeter and through the screw holes. So the other two, as I mentioned, are here and internally there. So this was the stock screw that went through the support into the housing, and you can see it's quite short. This is a 1/2 inch long, and it's a 5/16 at 24 threads per inch. So they used a lock washer on the back, and then between the support and the lens, there was another lock washer. So the problem with this approach is that a lock washer is not going to seal anything, and this lock washer sure as heck not going to seal anything either. Another issue that occurred is that you can kind of see that this lock washer really kind of chewed up these two surfaces. Now, an interesting aside, this is really the only situation where lock washers are somewhat useful for retaining parts one relative to another. Only when you have a relatively soft connection, meaning that this is a soft part and this is a soft part and there's a hard lock washer in between, the lock washer will bite into both parts and kind of keep them in the same orientation, more or less. Regardless, this turn signal was moving before, even with this lock washer, and also leaking. Overall, lock washers don't do anything. If you have high quality materials, these joints should be maintained through the tension in the fastener, right? The fastener stretches like a spring and keeps things clamped up together. Lock washers is really kind of just a waste, unless you have a situation like this where you have on either side of the lock washer you have relatively soft materials, but then you get damaged, so I don't use them almost ever. Okay, so what I'm proposing to do is, instead of using this short screw, we're going to use a longer one that's going to be 1 inch long. Right? So this is 5/16, 24 threads per inch, 1 inch long screw. What we're going to do is, first of all, let's lubricate it. I'm using Molykote 111. You can't really see the numbers here. It's basically a sealing grease, and it's going to keep the corrosion out and prevent the galling of the threads. Also on the head, I'm going to use just a little bit of gun oil here. Make sure it doesn't corrode too bad as it sits in that recess. And to provide the internal seal, the sealants inside here, I'm going to use, again, a metric washer, 12 by 8 by 1 millimeters thick, aluminum washer, just like you would use in your engine oil drain plug. It fits perfectly. It has absolutely the right dimensions. Didn't have to be modified in any way at all. Gonna drop it in. So that's our internal seal. The seal at the junction between the housing and the support is going to be provided by an M8 nylon washer, like so. Again, you can use SAE. This is just what I had handy, and you can see dimensions are absolutely perfect for this application. And then I'm going to, well, hopefully I'm not going to screw it into here, because that's what I'm using. We're going to put it in here, 1/4 inch long Allen bit. Oh, by the way, so notice that I marked the housing and the support before I took it apart to make sure everything is aligned. What I'm trying to do is I'm trying to align the face of this housing with the face of the headlight, right? So they're on the same plane. I don't want the headlight pointing one way, and by the way, the orientation of the headlight is pretty much fixed, and so I want them pointing in the same direction. So, okay. So now we're gonna screw this guy in, like so. So we just establish contact. So let's see. So now it's gonna get a little interesting because we're gonna need to turn the screw and hold the housing while we're turning the screw until we kind of get alignment of these marks. Let me see, we need to go a little more than 90 degrees, I believe. So let's see how that works for us. So now we're just tightening the screw as we're holding the housing, hoping that our marks are going to align. That's pretty darn good and quite tight. So now we have a good seal, and we should be pretty well aligned. Now, why did I choose a longer screw? Now we are pretty tight here. It shouldn't move. But I mean, you know, there's no kill like overkill. So what I'd like to do is I would like to put a nut here that would provide us maybe like a double nutting arrangement, right? So if this is nut number one, we put a second nut down and kind of lock them together, you'll have a lot less chance of this assembly moving, right? So what I'm gonna do is I'm gonna use a hard washer. Now remember, the clamp up, as I assemble this piece to this piece, is not coming from this screw, because it's a very hard material compared to this washer and the washer inside. So those are the washers that are compressing and providing the clamp up. This thing is very rigid compared to them. So it's, I mean, generally speaking, if you have a hard joint, it's the screw that stretches. I don't think that the screw is doing any stretching at all. It's the washers that are doing the compressing and providing the clamp up here, right? So in this particular case, I'm gonna use a nylock, and you can use a regular nut, but just in case if something goes wrong and this thing gets loose, I don't want it bouncing around all over the place. The reason I'm using a hard washer here is I don't want this nut chewing up the relatively soft material of the housing. So what I'm gonna do is I'm gonna use the 1/4 inch bit. And this is a 1/2 inch open end. Okay, now we're seated. Hopefully it won't change our alignment much. Let's see how we're doing alignment-wise. We still have our alignment, okay? So you can see what this looks like. Now we're going to check if we're still aligned. I'm going to put our screw into the lower triple clamp. Now remember, this is a critical fastener because it establishes the clamp up of the fork tube into the lower triple clamp. I am lubricating it. And the reason I'm doing that is because I don't want any corrosion. You have dissimilar metals here. This is a steel fastener, and this is aluminum here, so you have dissimilar materials. I don't really want to use anti-seize because of the mess. So I'm just trying to keep any electrolytic substance away from the junction. And so this grease is a very thick kind of a silicone grease, and it's just going to keep water or whatnot away from the threads, so we should be fine. But you have to keep in mind that you can't just use, now once you've lubricated the threads, you cannot use the torque that's in the manual, because now you have lubricated threads. It's much easier to turn this fastener because there's a lot less friction, so you have to offset this torque, and we can talk about that maybe in the next video, because there's another issue that you'll see we're going to run into when we try to torque this down. Okay, but anyway, let's just try to check alignment. I'm going to screw this thing in. kind of wiggle this thing around so it finds a place where it's the most comfortable around the triple clamp. Just keep tightening it until it seats. So we can check our alignment. We can just use this tool right here. So what I'm trying to do, I'm looking this way, trying to see if this edge is parallel to the side of the headlight, right? If essentially this and this are in plane. And we are right on the money. So what we can do now is actually tighten this thing down. If we have our torque wrench with our Torx bit, you can see that I don't have enough room to align the fastener with my bit, so I can't torque it. I'll do another quick video, hopefully demonstrating the solution to this problem. In the meantime, I'm just going to replace my lens with a gasket. I'm gonna again use Molykote 111 around these threads a little bit around this washer just to help things seal. Put the bulb in, put a little bit of silicone grease around the base of the bulb, and we should be good to go. I'm gonna put just a little bit of gun oil here. To keep things from getting too dry. And you can see, because I haven't snugged it down, let me maybe do a little bit more before I start torquing it so it can find its position better. Here we go. So hopefully I can demonstrate how I torque this thing down in part 2.